appreciate the opportunity to speak here and the wonderful introduction. It's a great conference. I've been there the last 2 years. I couldn't make it this year, but I'm happy to participate virtually and to talk about the concept of how can we get people building Zephyr code faster. So one of the worst things about embedded development, I think, is managing tool chains and managing build environments. There's a long sordid history of it, and things are so much better now. But we still find that even with the strides that Zephyr has made in kind of encompassing an ecosystem, getting that first local install up and ready to build can be challenging for a new user. And that might not be the best first introduction. So we've been looking at ways around that, and that's what I'm going to talk about today. I think we can get everything done in a browser tab about 95% of what you would normally do locally, which is pretty cool. My name is Mike Szczys. I'm a firmware engineer at Golioth, and I split my time between the developer relations team and the firmware team. If you haven't heard of Golioth before, we're a cloud company, so we look at making it really easy to put microcontroller level devices into internet-connected fleets. And we rely really heavily on that for Zephyr because we're hardware agnostic. So the cross-platform support that Zephyr has is really important to us. We deliver a couple different parts of this cloud product. One is just the device management. Like if you have 10,000 devices and you need to get different builds of different firmware for different revisions, how do you manage that and make sure they go where they should? How do you do things like update sensor calibration to all those devices or deal with getting debug logs back if you have misbehaving devices? And the other side of it is just dealing with all of that data, right? So you have this huge fleet, it's got sensors, you're sending data back. We have like time series data and stateful data. We make it possible to send that to wherever you want it. So if you want it out on like AWS or Azure or whatever, onto your own servers, onto your Influx or Mongo database, like wherever you want it to go, we take care of that kind of messy middle of getting the cloud side to talk to the embedded side in a way that is smart and works. And like I said, a big part of that is Zephyr. The problem is getting people to try it and to test out Golioth often means having to build Zephyr applications. And so we want to make that as frictionless as possible because we find people that try Golioth like it, but you have to try it out the first time. And so one of the things that we've done there is we started hosting free monthly Zephyr trainings to kind of get customers and potential customers up to speed. And that went pretty well. And there's a hunger for that and appetite for that. But we found on those early trainings, we spent most of the training time just setting up the tool chain locally, which is not great. And so our most recent advancements on this have gotten us really close to a streamlined behavior that I'm going to demonstrate today. It relies on Codespaces, which is I guess it's a Microsoft product. Codespaces is owned by GitHub. GitHub's owned by Microsoft. It is free to use up to a certain amount of use. It's something like 120 core hours and, I don't know, 16 gigabytes of storage or something like that, which we find nobody gets close to in a 3-hour training that we do. But it's not just this Codespaces product that I'm talking about. It's actually built on top of an open protocol called development containers, an open standard. And you can also run those VS Code. I haven't checked. There's an open source fork of VS Code as well. I haven't checked to see if it runs in there, but I suspect that it does. Let us know in the chat if you know about that. So let's take a look at what Codespaces looks like. So I'm just going to go to this Zephyr repository that we have on the Golioth org under Zephyr training. We have several different applications set up here that we go over during the training. But we have this one folder right here called dev container, which does something kind of magical. And I am going to zoom this just so in case there's trouble seeing it. This code button that you would normally go to get the git clone URL has a Codespaces tab on it because of that dev container. And I can actually click and set up a new Codespace just on main of this. And what this is going to do is it's going to kick off a container build on the cloud somewhere. I have no idea where. And you can see it looks very much like VS Code because it is VS Code running in my browser. Now it's going to take just a minute in order for this to build, but I want to go and talk about how this repository is set up. So this is actually set up as a manifest repository.
Mike,
If you
quick
haven't
question.
heard,
Can you
yes,
change the contrast a bit? Because that's just not coming through the video very well on your screen. The white
contrast.
and the grass. Yeah, between you've got night mode going on here, and it's
Okay,
pretty grayed out from the video from
interesting. All right.
projections. Thanks.
Yeah, let's see. Probably go here and then settings maybe, and then appearance and light default like that. Maybe. All right.
That'll probably help. And make the font a little
Okay.
bit bigger. Thanks. The back
All right.
person
Okay.
in the back row is me. Can't see it. So
Yeah. All right. All right. So I was talking about how we have this laid out, and this is what's referred to as a manifest repository. If you haven't experienced that yet, I'd encourage you to go take a look at this talk I did last year at ZDS on manifests, which sets it up so that we lock everything that we're using, all the dependencies to a particular version. So in this case, I can look in the West manifest and you can see I'm including the Golioth module, which then imports a bunch of other modules, including like Nordic, Zephyr, all these things. And these are all locked to a specific version. And so this repository is going to install everything that you need tree-wise. The only thing it's not going to install is the tool chains, like the SDKNG, which is like the compilers, which I'm going to show you as part of our code spaces. All right, so in all of that talking, I've given this code space that I launched previously. And I'm sorry, Kate, I don't know how, oh, maybe I can do this. Light modern. Hey, there we go. All right, excellent. And I probably also need to make this bigger. All right, so this is VS Code running in a tab. This is our code space. It is running on the cloud. And you can see this has an app directory in it with all of those things that we were just looking at in the repository, including this dev container and then all of our sample code here. And I can even go into the app directory and I can right off the bat do a build if I type the correct letters. All right, let's see, 9160 DK, NRF 9160 NS. So we'll kick off a Zephyr build right there. Oh, no. Oh, I didn't give it the name of the app that I wanted to build. There we go. All right. So we kicked off a build and we're not going to watch the whole thing. Oh my, oh my. Having troubles. Live demos, right? Did I type something wrong? Yes, I typed an F instead of a K. All right. This is totally going to work now. All right. So our build has started. That's pretty quick. So it does take about 40 seconds for this to load for me and then the normal amount of build time right there. But it's a really great experience because all the code that people are building is right here. The code editor's right here. We're able to build it right here. The only thing that we don't have in this code spaces is the ability to actually use West Flash and flash the board. I guess you also don't have the ability to do like a West debug or a West attach. So that's that other 5 to 10% of the process. But for the most part, if you're having someone that's just starting out with Zephyr, getting them to actually look at the code, change the code, build the code is a big part of it. We have it set up so that we download the binaries locally, and I will show that in just a moment. But let's jump into what this whole kind of process is. So I mentioned before that any repository that has a .dev container folder in it and contains a dev container.json file is going to be treated as a dev container project that you can load up on Codespaces. You can also run it locally, which I'll go into in the next section. But in this case, if I just look at that dev container.json file, it has pretty much everything in here that you need. There is one external file, which is on line 5 here. It says on create command, and then it runs a special command. I'll get to that in a moment. But the top 3 lines are what actually sets up the container for us. Golioth maintains our own like minimal Zephyr tools container. So it has like a minimal Debian on it, and then it just has the compiler tools built into it. On the next line, which is workspace mount, I am setting up a local workspace folder and I'm telling it to bind that to the repository app folder. And if we look at how we have our YAML file set up for this, we're telling it put our repository into a subfolder called app. And so that's why we set that up as the same thing right here, app type bind, right, for the training folder. And then we set a workspace folder, which says always start us off in the Zephyr training folder. And that's so that when we open the code spaces, that's what we get in our Explorer as the main thing. So you can see here's our Zephyr training. Here's the app folder that has all of those files. And then when it actually does a West update, it installs this deps folder with all of our dependencies. So there's the Zephyr tree right there. And we can see again in our manifest file, it's because we're using a path prefix of deps right here. So if we go and look at the next part of this is the actual create command. What this is doing is it's going, all right, we have a Docker container all set up. We have the image. We know where we're going to mount things. And then once the container starts running, it's going to run these tasks in order to kind of set everything up. So you can see, I'm actually going to go in here and work through it because I'd like to be able to highlight things a little bit better. All right, so I'm going to go into on create command, close this. And I'll make this a little bit bigger. Oh, there we go. All right. So in this, you can see the West init command. If you use a -L that says, hey, we already checked out the repository, so use a look for a manifest file locally and look for it in the app directory. So that just kind of gets West set up for what we've checked out. The West update, as I said, that is what is going to create the steps folder and pull all of our dependencies in. We run the West Zephyr export, which sets up our CMake. I'm sure it's a little bit hand-holdy for me to go through all this because people at this conference have probably done all this a million times. But we also want to set up our Python tools with all the dependencies that are required by Zephyr. I like to use the ll command to list files in Linux, so I've just customized our shell a little bit to be able to use that command. And then this is a handy one if you haven't seen this before. The West tool does include auto-completion for board names, so you can do tab auto-completion, but you have to set that up. So I'm setting that up as well. And then finally, I don't want all of these commands to be in the history. Like if you're at the terminal, you do an up arrow, and so this history-c kind of deletes that past history so that when users start our training, they don't accidentally get these commands coming up, which can be a little bit disconcerting. If I go back to my container, let's see, maybe in my slides. So right here. All right, so we've taken care of these first 4 lines, the image, the workspace stuff, and the on create command. We get to the rest of this, which is the remote environment. This kind of maps some environment variables from your local machine into the container. And then kind of the important part for your application is customizations. So some of the things that I always like to do, these refer directly to VS Code. So you can see that under the VS Code node right here. I always like to have the CPP tools, which is, just general linting and language server stuff for the C language. But also Nordic has some great extensions for VS Code for code highlighting and linting device tree and kconfig. And especially when we're doing a training and we're talking about kconfig and the device tree, for a lot of people, it's the first time seeing those things. Like having a linter code highlighting there is really great. So I make sure those get installed right away. The other settings here, this is basically to make VS Code less noisy. I generally use Vim instead of VS Code most of the time, and so I find the experience of like these pop-up windows really jarring. And so this just kind of quiets some of this, and it's kind of trial and error on getting that in there and getting that to work. So other than the customization of VS Code itself, there is one other thing that we did to customize the repository, and that is making it easier to get at the binaries themselves. So remember before I said you could not use West update because the USB port is not connected to this container where we previously built our code by maybe new terminal. All right, here's our code build that previously finished. You can see the output here. If I run a West Flash, I'm going to get an error here because we don't have the Flash tools installed and there's no board actually connected to whatever computer in the cloud is running this. But we added another command called West download. And so what that does is it goes and looks for the binary file that we're using, and it will create a downloads directory in our workspace, and then it will copy that with a renamed file name. Just a little wider so we can maybe see that. Okay, that's weird. All right, here's our file name. It has the board that I built it for, and then the app that I built, and then a timestamp so that if you're rebuilding and re-downloading, you don't get kind of confused on which thing you're building. Let's see, do I get the editor window back? Explorer, there we go. All right. All right, so you see the downloads folder right here, and in the downloads folder, there's the file that we just moved with our script, and you can click download and it will pop up a window for you to download it locally, which I'm not going to do. At that point, Nordic has a bunch of great tools like NRF Connect for desktop has a programmer in it. It also has a serial terminal in it, and they're cross-platform for Linux, Mac, Windows. So any users that come to our training, they can open this Codespaces on their machine. They can download the files onto their machine, and they can use the Nordic tools to flash those files to the device and then to see the serial output to the device. And we have basically no hangups for what operating system or computer, whatever browser you've decided to use, which is amazing. So I really appreciate that. I really like the ability to do that. If you're wondering about that custom command, let's see on my slides, I think I have some stuff here. You can see that I have just a subdirectory, utility, West command, and a couple of files in there. This is taking care of what's called the West extensions that lets you add these custom commands. You can find that in the Zephyr documentation. And then if I actually look at, well, let's look at the manifest file. Down at the bottom under self, remember we had this path to put it in the app path, but we also have this which says, hey, I have custom West commands, go to this location and look for them. And if I look for them in the browser right here, I can see the YAML file will tell you, all right, the file to run for the custom command is also in this folder, West download. The command you're going to use is download, and there's some more help stuff here. And then I'm not going to go through any of this Python stuff, or maybe I should just mention, like here, you can see we're actually filtering for which board we're building for so that we get the right binary name. So I think that's pretty important. If you're doing something like, I think Espressif generally needs to have its binaries merged together. So some things to look at for that. But if you need a workaround for something that doesn't happen because you're on the cloud and not at your local computer, this is a good way to do it. All right. The other thing that we take advantage of here, I showed all of those kind of initialization commands like the West update. West update can take a really long time if you're pulling down the Zephyr tree and the Nordic NCS tree and all of that. And so if you don't want your user to have to spend like 5 minutes waiting for the container to build, or I guess more the first time, you can do something called a pre-build, which runs through all of that and then stores it as its own container in Codespaces. And that's what we've done. It is really economical. Like it's a very small fee. You will be charged something for it by GitHub. The other thing that I like to point out is this, in general, this use of Codespaces has great worldwide support. So we had previously been using a container-based solution, and if we had users that were like we had just one server, like maybe in San Francisco or something, if you have users that are like in Eastern Europe or Asia or like somewhere a long way away from there, it can cause bad latency. But we found that GitHub generally has enough servers in different places that people aren't dealing with those latencies. The Codespaces are running in regions where they are. The other thing that I tried in looking at this is I really wanted to see what it would take to run this locally. And it takes almost nothing. Like if you open the folder that has a dev container folder in it, VS Code will pop up a thing that says, this has a dev container folder in it. Would you like to install the dev container extension? And once you do that, it pops up a message that says, this is a dev container. Would you like to build it? And then as you make changes to it, it's it's funny because it's almost like doing brain surgery on yourself. Inside the dev container that's running locally, you can update the dev container.json file, and then VS Code will rebuild it. You just have to be careful that you don't make syntax errors, or then it will not rebuild. It will be broken. Ask me how I know. But it makes it very easy to run these containers locally. There are some prerequisites. So I already had Docker installed, so you definitely need Docker installed. It will take a while to download the images the first time, depending on what you're doing. So just be aware of that. But once they're downloaded, then your images are cached locally. So it makes it pretty quick after that. The containers may or may not continue to run after you exit. So there is like, this is like VS Code on top of an instance of Docker. And so the things like, do I have a whole bunch of images stored from previous builds? And do I have containers that didn't get killed that may or may not be running in the background? Just know that some background knowledge about Docker is kind of necessary in using this. My next question, of course, was, all right, I'm running it locally. Can I use West Flash with this? And I looked into that a bunch. The answer is kind of yes. I'm on Linux, so I can run, I can connect it to my USB devices. It's not super simple, and I'll go over that. However, there is no support for Windows and Mac on doing this yet. So I think that's a Docker limitation, but I may not be right. One of the reasons that I don't feel comfortable running this on Linux in general is because you have to run it in privileged mode. So the changes to the JSON are pretty simple. You mount your USB endpoints or USB path from the system into the container, but then you have to tell it run in privilege mode. So privilege equals true. And that basically runs everything in the container as root, which I'm not super excited about. So I did this as an educational experience, but I wouldn't necessarily recommend it. Once I tried to actually flash, then it gave me the same error that I had when I demonstrated it just before, which is the flash tools aren't installed. So I used some tips from Nordic's container that they have in order to install the Seger and the Nordic command line tools. And I did this in that on create commands script. So it happens after the container builds. Now, if you were to build these into the container, then you wouldn't have to install them subsequently. The other thing you can do is if you have them installed locally in your system, you could bind mount them into the container. There's several different approaches to do it. And I did get it working. I don't know why I didn't put a slide in here, but you can do West Flash. It does totally work. It took me, I don't know, probably 2 hours to work through all of the stuff that wasn't in the container and rebuild it and all this stuff to get it working. It does work. But with Codespaces, one of the big questions that we have is why not use WebUSB, which sounds like a great idea. If you haven't seen WebUSB before, I think the demos that I've seen for it are like you have a flasher tool where you don't install a dedicated app on your system, but you can just go to a web page and it will have awareness of a device that's connected through USB, and you can upload in your browser the binary and then it gets flashed to the device. So that's pretty much what we're doing with Codespaces. We should be able to do it. I went and looked for it. And if you search the docs on Codespaces for WebUSB, there are no mention of that. So not currently supported there. The other thing is my perception is that WebUSB is only really truly supported in Chrome. I saw that there might be some Firefox work, and I'm not sure where that is. But one of the things that I really liked that I mentioned before is that the cross-platformness of this is really desirable. So being able to not have to tell a user switch to Chrome or switch to whatever operating system is good. And so for now, we're fine with the workflow that we have where you download the binary and flash it locally. I think that this could be useful for a number of things for us. We're already using it. We've used it several times this year for our Zephyr training, and it has been great, really easy to support. People know VS Code already, and so they feel comfortable in it. It's been wonderful. A place that we're exploring, we have a number of different Zephyr samples in the Golioth module, Zephyr module, and it would be nice if we had a dev container for people that just want to like make small customizations and then compile the code and run it on their board to kind of like validate Goliath as an option for their company. And so we're looking at possibly adding that in. I also think, one of the places is kind of getting back to a snapshot in history, right? So if you have a client that has launched a product based on Zephyr and that product's been in the field for a long time and the code has never been updated, and then they have a problem that needs troubleshooting, how do you get back to the build that was used when that was first released? So Zephyr is really good about that with the manifests and that manifest repository approach that we take with ours. But the thing that's different is we build with whatever tool chain is installed on the machine. So whatever compilers are installed on the machine. I could see a use case for these dev containers where you have a different Docker container for each version of the Zephyr SDK NG, so that you get back to the actual compiler tool that was used when it was originally compiled. I think that would be quite useful. But if you have use cases, I'd love to hear about them. Reach out to us on Goliath. A couple thank yous. I'd like to say a big thank you to Jonathan Barry, who is Goliath's founder and CEO, because he was the one that put together the dev container for this and said, hey, look, it works. And then he was the one that put together the code spaces and figured out the pre-builds for it, got all that set up and running. And so the DevRel team was able to come in, basically dump the training code repository in there and then start using it right away, which was super cool. If you do want to try out any of the examples that I did, the top URL right here, the Zephyr training on the Goliath org of GitHub has that in it. If you want to see what our training is like, even if you already know Zephyr, that's fine. Join us. There's a sign-up sheet. We do it every month, and it is free. Here's a link to the containers.dev, which is the open standard that we're building on top of. And then, of course, the Codespaces, which is a GitHub feature, is listed here. And if you are ever looking to connect a ton of devices to the internet, you should give Goliath a try. It is free for individuals, and we'd love to talk to you about your use case. That is it for me. Thank you so much. Are there any questions?
Thanks, Mike. I've got the microphone, and I'm just waiting for it. First hand is up. Go for it, Drew.
Yeah, so just real quick, do you have any sense for how GitHub Codespaces specific this is? My understanding is there's like some, different third-party code spaces like things, and with dev containers, is it all fairly standardized?
So I think the dev containers is fairly standardized. If you go to this containers.dev, it's an open standard, and I believe it was kind of in Microsoft's intention, or at least when I talked to Jonathan Barry about this originally, he said it was Microsoft's intention to make it a standardized thing. I haven't tried out any competitors though, so your mileage may vary.